Hello, my name is Haitham Suleiman, and today we will be continuing to solve our physics problem in terms of Form 1 syllabus. And today we are going to enter our seventh topic, which is called Light Part 1. Okay, so before that, we have to know what light is. We can simply define light as an invisible form of energy that causes the sensation of vision in us through our eye, right? So it is a form of energy that causes the sensation of vision. We're able to visualize by using this type of energy through our eyes. That is the simple definition of light. And now we are going to solve some few problems about light. The first one is going to be write four properties of light. We have already said that light is some sort of invisible light, invisible form of energy. It means you cannot see. So we should write four properties of light. How do light behave? How can you know? How can you characterize light? So these are the properties of light that we are going to discuss. Answer. So the first property is light transfers energy. So when light falls on a certain object, it transfers energy to that object. That object gains energy when light falls on it. The second property is light travels in a vacuum. The second property is light travels in a vacuum. Vacuum is simply an empty space, and the space that has no particulates, that has no air, that is called vacuum. So light can travel even in vacuum, in empty space. Example, the light energy that we get from the sun actually has to travel in space for it to reach here on earth, to reach our eyes, for us to see. So that is a property of light, because there are some other materials, there are some other matter, there are some other physical properties that cannot travel through vacuum. But light has this property that it can travel through vacuum. Also, another property of light is light radiates or spread out from its source. Okay, so assuming that this is our source of light, this is the sun. So light has a property of radiating or spreading from the source in different direction. This is what we call property of light. It radiates, it spreads in different direction. It travels in form of rays. We call this rays of light. It travels in form of rays, just like parallel lines which show the direction of light. And then we have the fourth property. It's called light travels at the fastest speed. Okay, so we know that there are some racing cars which travel maybe with very, very high speed, and we're like, wow, that's a very huge speed. But actually, light has the fastest speed record to have ever been observed. Light travels with a speed that is 3 times 10 exponent 8 meter per second. This is very huge number. So light travel at the fastest speed. So we have seen the four properties of light, which are light transfers energy, light travels in a vacuum, light radiate or spread out, and light travels at a very fastest speed. These are some properties of light. Continuing, let's go to our next question here, which says define transparent material, translucent material, and opaque materials. So, in light, we have three types of materials. We have transparent materials, we have translucent materials, and we have opaque materials. What are these? This is what the question wants us. It wants us to define. So, in order for us to define, we have to know what those are, right? So, let's see. Okay, so these are my answers. Transparent materials are materials that allow materials to pass through them. Example, glass. Actually, this is supposed to be are materials that allow light that allow light to pass through them. Example, example, glass. So we know in our environment we have some materials which allow light to directly pass through them. When a ray of light strike that surface, it allows it to pass. So those materials are what we call transparent materials. Example, glass. If we have light in this room and we have a glass door, the person in front of the if in front of the door, which is not in this room, is going to see the light, because the glass is a transparent material. We have also another material, it's called translucent material. These are material that allow only some part of light to pass through them. Example, oil paper. So there are some materials which do not allow all the light that strikes on that surface to pass. It allows only a portion of that light to pass. Those materials are what we call translucent materials. Example, an oily paper. I'm sure most of us have tried to take a piece of paper and then to oil it and then to try to draw something by keeping it in above the picture, right? So that oil paper acts as a translucent material. It allows the light that comes from the picture in the paper to reach us so that we can copy it. And then we have another type of material called opaque material. These are materials that do not allow any light to pass through them. That do not allow any light to pass through them. These materials are called opaque. So, according to this definition, can you think of some materials that do not allow light to pass through them? Hmm. Book, wall, even your hand. When a ray of light passes through your hand, it cannot pass through your hand to come to the other side, right? So that is an opaque material. So those were the definitions of transparent material, translucent material, and opaque material. So here I have some notation. It says that objects that emit light as a result of being heated are called incandescent materials. Example, light bulbs. So there are these objects that do not emit light, but when they are heated, they emit light. These are called incandescent material. What? Incandescent materials. Example, light bulbs. When you take a light bulb, it will not emit any light. But when it is heated, when the electricity passes through that and it gets heated, it starts to emit light. That material, light bulb, is what we call an incandescent material. That's why for some of the light bulbs, when the electricity goes off, it still shows some light. Why? Because it starts to lose heat more like slowly. That's why the heat is still there, and that's why we are able to see the light. Okay. Luminous objects are objects that emit their own light. Example, sunlight. So there are these objects that emit their own light. They do not require to be heated just like the light bulb. They can emit their own light. These are what we call luminous objects. Example, the sun and the star. The sun has its own light that it emits, so as the star. That's why when we see the stars at night, they emit some light, so as the sun. You might ask yourself, what about the moon? Here is your answer. Non-luminous objects are those objects that do not emit. This is supposed to be emit that do not emit their own light. So we have luminous objects that emit their own light, and we have non-luminous objects, which are those objects that do not emit their own light. They are only visible, it means we only see them when they reflect light from another source into our eyes. Example, moon and planets. So here we find out that moon actually does not have its own light. We see the moon because it reflects light coming from the sun. So, if you were to go to the moon, you would also see the earth from the moon. Why? Because the earth as a planet, it also reflects light coming from the sun. So actually, the light that we get from the moon comes from the sun. Good. So those were three notations that we had to consider. Now let's go to our third question, which says define reflection and state the laws of reflection. Right? If you remember very well, I told you that the moon on was I told that the moon was only visible because it reflected light from another source, which was the sun. So here we get the word reflection. What does reflection mean? That is our third question. So, reflection is the throwing back of rays of light when they meet an obstacle in their path. So when light, assume this is our ray of light, it's going this way and then it meets an obstacle. This is our obstacle here, it meets it, and so it gets reflected. So what is reflected? What is reflection? Throwing back. It is thrown back of rays of light because they have already met an obstacle in their path. So the throwing back of rays of light when they meet an obstacle is what we call reflection. The direction of reflection depends upon nature of the surface. So we have two types of surfaces. We could have a smooth surface like this. This is a very smooth surface, and we could have a rough surface, maybe like this. This is a very rough surface. So when a ray of light encounters or meet this smooth surface, this ray of light is coming, and then it meets this smooth surface, it gets reflected back like this. This is going to be the direction of its reflected ray. But when it meets a rough surface, it is going to be reflected, but not exactly in the same direction. It is going to be scattered in different direction because it has met a rough surface. You understand? So the direction of reflection depends upon the nature of the surface. Okay. And then we were supposed to state that the laws of reflection. Reflection has two laws, which are reflection has two laws, which are the incident, the incident ray, the reflected ray, and the normal all lie on the same plane. All lie on the same plane. What does this mean? Okay, this is our horizontal plane, and this is the incident ray, and this is the reflected ray. So if we were to draw a perpendicular line from this point of intersection, if we were to draw a perpendicular line, um, yes, and call this as the and call this as the and call this as the normal, and this is our incident ray. This is going to be our incident ray, and this is going to be our reflected ray. So we can see from here that the normal, this perpendicular line that divides our incident ray and our reflected ray into same portion, into it divides the angle into two. If this is the angle, then maybe the angle is theta is going to be theta over 2, and here it's going to be theta over 2 if this is our angle. So we can see that the incident ray, the reflected ray, and the normal, they all lie on the same plane. So that is our first law. And then our second law says that the angle of incidence is equal to the angle of reflection. Okay, allow me to elaborate. So if I have this is as my normal and this is my incident, let's call this as the angle of incident. This is my incident ray, and this is the angle that it makes with the perpendicular line, the normal. This is the angle that it makes. Let's call this as the angle of incidence. And then I have the reflected ray, and it also makes an angle. Let's call this as R, which is going to represent the angle of reflection. So, according to this law, it says angle of incidence is equal to the angle of reflection. So, if I have a plane surface and then I have a ray of light that falls on it at maybe, let's say, at an angle 60, then the reflected ray is also going to go at an angle of 60. Understood? I hope so. Okay, so let's continue. Here we meet our fourth question. Here we meet our fourth question, which says, draw the following rays. Draw the following rays. Before that, let's look at the definition of ray, right? This is the definition of ray. A ray is a path taken by light in moving from the source to another point. So if this is the source of light, and then the light moves in this direction from this point to another point, this path that it takes is going to be our ray. Is the path taken by light in moving from the source to another point. This is going to be ray. So if we have so many rays, assume that we have maybe 3 rays over here. We have a collection of rays. We are going to call that as beam. So if those are rays of light, we are going to call them beam of light because there's many rays. Okay, so the question wants us to draw the following rays. First, convergent rays, parallel rays, incident rays, and reflected rays. Okay, let's do it. Okay, let's do it. The first one is convergent rays. To converge, it means to come together. So we have to draw rays that are coming together. Okay, so for A, this is going to be our drawing. We have this ray, we have this ray, and then we have this ray, and they are all coming together at this point. So we put our arrows over here to show that these are convergent rays. Okay, good. The second one, parallel rays. Parallel rays are those rays that should not that should not cross each other, because parallel means something do not cross each other. So this is very simple. We are going to draw our rays simply, maybe let's say horizontal rays that do not cross each other. So this is our parallel ray, and then we have to draw incident rays. Incident rays, to incident on something means to strike on something, to come. So incident rays are rays which strike the surface. Those are what we call the incident rays. So if we have our surface over here, this is the drawing of C. So if we have our surface over here, we have to draw rays that are incident. So it means they are striking our surface. These are called incident rays. So anyone who comes and sees this drawing is going to know that, oh, these are incident rays. They look like they are going to strike the surface. And then D, we have to draw reflected ray. A reflected ray are which are not transmitted or absorbed but bounce back when they meet an obstacle. So they are not transmitted or absorbed, but they bounce back when they meet an obstacle. So we said that sometimes light can be transmitted, right? It can pass through it can pass through the object to go to another side. So if the ray is reflected, it means that it's not transmitted. It bounces back. It goes away from the surface. So if we have or any obstacle, it doesn't have to be the surface. It could be a window, it could be a glass, it could be anything. So we have to draw rays here. Rays are simply lines that are reflected. It means they have already met our obstacle. For here, it's a plane. They have already met the plane, and now they are reflected. So anyone who comes and see this drawing D is going to know that, oh, these rays are reflected. So a quick summary: these are convergent rays. They are coming together. These are parallel rays that do not cross each other. These are incident rays that strike the surface, and these are reflected rays that bounce back when they meet the surface. Okay, great. Okay, so let's see our next question here, number 5, which says, write 4 characteristics of images formed in a plane mirror. So we know that like the mirrors we use in our house, those are plane mirrors, and they have some characteristics, some behavior, some properties. We are supposed to write 4 characteristics of those images formed in a plane mirror. Let's see. The first characteristic is the image has a left-right reversal. The image has a left-right reversal. This means that your left, the image is going to be your right, and your right is going to be your left. They are reversed. It can be yourself, it can be letters are reversed. Example, let's look at this word. So if I write here jumbo and I bring it to a mirror, the mirror would show me an image in which this word jumbo is going to be O B M A J. You see, the left rights are reversed. So this is the first property, that the image has a left right reversal. The second property is the image is the same size as the object. The image is the same size as the object. If the size of the object is big, then the image is also going to be big. And if the size of the object that you are viewing is small, then the image is also going to be small. It is not like if maybe you are viewing this pen and you see a very huge pen. No, in plane mirror, the image is the same size as the object. That is the second characteristic. The third one says the image is at the same distance behind the mirror as the object is in front of the mirror. So maybe if you are a distance of 2 feet away from the mirror, the image that is going to be formed is going to be also 2 feet behind the mirror. You understand? So same distance behind the mirror, just as the object is in front of the mirror. It's not like if you are maybe you are close to the mirror and then the image shows you are very far from the mirror. No. Characteristics of images formed in plane mirrors should be the same distance in front of the mirror, should be the same distance of the object, same distance behind the mirror. The image is formed same distance behind the mirror as the object is in front of the mirror. And then D is the image is upright. Upright means it is not inverted, right? Because sometimes when you view pictures, you see that the floor is at the top and maybe trees are reversed, they are inverted, but that is not the case with images formed in plane mirror. It is always upright. So if you are standing tall, your head in the image is also going to show your head as the above part and your legs as the up down part. So that is one of the characteristics of the image formed in plane mirror. So a quick review of the characteristics. It has left right reversal. It is the same size. It is at the same distance. The image is the same distance behind the mirror as the object in front of the mirror, and the image is upright. With that comes the end of our solving in this topic called light. Thank you.